Hey everyone, Keegan here again, and I wanted to bring you something a little bit different today. So at Orbtronics, we talk a lot about building the Caribbean's innovation future, but the best way to show you what that looks like is to introduce you to the people that's building it with us. This month, we've had the special edition of an intern who came to us from Columbia University from New York, and he spent the last 4 weeks on research that literally reaches for the moon. And spoiler alert, he got some life-changing news while he was here with us as well. Antonio, welcome.
Awesome. Yes. Happy to be on this, interview. Yes.
So before we get into the work, tell our audience a bit about yourself. Who are you? What are you studying at Columbia? And what made you choose to spend a month of your summer with a tech company in St. Lucia?
Yes, of course. So I am, like you mentioned previously, I am a sophomore at Columbia University. I'm a rising junior, so I'm becoming a junior next year, and I study computer science and architecture. And the reason why I'm here in St. Lucia is because I'm a part of something called the Laylaw Scholars Program. So the Laylaw Scholars Program is funded by the Laylaw Foundation, and they send students like me around the world to, basically do something called a leadership in action. So going to communities and applying the research we did last summer to improving these communities or helping out with whatever ways you can.
Yeah, I think that's a really interesting program, and I think I also want to get, so why did you choose St. Lucia?
I would say it's because I had a friend who came from here. So Nehal is a common friend of us, and he introduced me to this opportunity. And I thought it was interesting to, one, see what it is like to have the tech environments in these different countries, different from the US and China, where I'm more familiar with, and how a lot of these smaller countries like St. Lucia are dealing with the recent tech boom in AI and whatnot.
Okay, cool. So let's talk a little bit about what you've actually been working on, because I think maybe for some of our audience, it might sound like science fiction.
Yeah.
You've been building research around the virtual control of a swarm of autonomous vehicles. Break that down for us, and what does that mean and how does it work?
Yes, of course. So I'm working with Keeghan from the Orbtronics team, and our goal is to build sort of like a Martian rover or lunar rover thing that can be controlled by AR, VR via like a swarm control. So you have in essence a headset, like a MetaQuest 3, it's a VR headset, and you can use it to control, let's say, multiple robots to do different tasks at once. The idea, I believe, is that on the moon, you can't really go out to do tasks because it's a very restrictive environment. So you would have these robots go out and do things for you, and you would control them via VR. And it's been going well. I think we're going to finish the rover hardware today. And then afterwards, we'll do a lot of software work and get the control system up and running.
Cool. When you got the design prompt from our engineering team that you were going to be working on this virtual control environment and also going to be working with various robotic systems, what were some of your thoughts on the initial design space? And maybe what interesting angles did you think you could bring to the team coming from the US universities?
I must say I was fairly shocked to hear like a very ambitious project here. I think it's very surprising, a very pleasant surprise though. And I think in general, my thoughts was that some control of like autonomous devices are increasingly becoming in the forefront. I think physical AI or physical control is very much in the modern zeitgeist, or in the modern sort of commercial space, is very popular right now. You can see this with a lot of large robotics companies raising tons of money. With regards to the sort of specifics of it, I think the lunar rover is definitely a good idea, because I think the world's also moving towards a lot of more off-board projects. I think recently SpaceX is actually going for an IPO, which is going to be interesting to see that coming out. With regards to specific insights, so I do a lot of work on AR, VR beforehand. I'm in the CGUI lab in Columbia, and so I've done some control systems. In fact, my research this summer would have been on control systems as well. And also in terms of robotics, I think it's interesting to explore different sort of mobile bases. So a rover base is an extension of what I would call a differential base. You have different modes on each side, and then there's a little bit of swerve. That's what the rover base is. Yeah. It's cool to see them adapt like a sort of larger system with the pivots to make it more able to control itself and be able to cruise smoothly across less favorable terrain, which is what you would find on the Martian landscape, or even just outside actually on Earth.
Yeah, cool. So here's what I find particularly incredible. This isn't just like an academic exercise. I think this research is a stepping stone forward to controlling fleets of vehicles in places humans can't easily go, whether it's on Earth or in lunar environments. But paint what looks like the big picture for us. Why does swarm control matter for somewhere like the moon?
That's a good question. Basically, like the moon, I mean, once again, storm control matters because humans are not the best at living on the moon, right? I think in general, like when you're on the moon, you're either inside into your base, or if you're going outside, you have to build on a really big, bulky suit to block radiation, and also because there's no air on the moon at all. So the idea that initially you would only send up robots up to do the initial construction and to do different works makes a lot of sense, especially for that it's a very hostile environment for people. I guess beyond the moon in general, again, with the rise of like physical AI, the rise of these improvements in control policies for these AI, it becomes increasingly possible for robots to do things that would once have required human labor. So let's say on a construction site, in maybe 5-10 years from now, you would see robots doing the majority of the harder constructions, and it's sort of people sitting inside air-conditioned rooms and just controlling them, right? It's a more ideal environment for work. It also makes like work easier and cheaper for a lot of people.
Cool. Find that immensely interesting. So I think let's broaden the scope because you've been here with us for 4 weeks and you've done so much work even outside of just academic research or this research project. But you've also worked with our first global team, and you also got a chance to work with some underprivileged and special education students from SUFER.
Yep.
Tell us a little bit about that educational and imparting knowledge side of the internship.
Yeah, I mean, of course, I think like quite a crucial part of any sort of scientific breakthrough or any robotics breakthrough is about communication. And it's about like sort of leading the next generation or current students into the field and having them, grow a similar interest as well. Working with the robotics team here, I think it's very exciting. I used to do a lot of these robotics competitions myself, and I think it's a fantastic initial stepping stone for people to then move into a more formal mechanical engineering practice or even a computer science practice. It's always wonderful to work with like people who are younger and then who are like having that initial foray into them, because you can see like they have a really strong fascination into the subject, and you want to sort of guide them into a stronger interest to learn more. With regards to like the work with the special needs community here, it's also very interesting because obviously it's a lot less technical, right? You're not expecting any of these special needs kids to go into like the details of the physical elements of it or even programming. And it's a lot about it's like sort of making what would be a very complex engineering lecture or a very complex robotics sort of lesson or something like that into something that's very approachable for people who are not as interested in going too much in depth. So I remember when we had a class was that we just gave them robots and had them play with it, like play with the controllers and everything, showed them what it was like to be in a VR environment, and then walked them through some basic Arduino stuff. I think the theme they had was reading, and we connected like reading to programming, all these kind of things, sort of building that fascination with robotics beyond in a formal academic sense, and sort of giving them an initial look into what the field might look like is also very interesting to me.
Cool. Yeah, I think the work that you've been doing with the team is like immensely valuable, especially being able to impart that knowledge from being in other environments. And I think you have a very global perspective being from Canada, very strong presence within China, and also going to school now in the US. I think there's a lot of information that you're able to impart to the students. And it's I'm very excited to see what our first global robotics team might be able to learn from you as well. Outside of that, you've traveled, I think this might be your first time to St. Lucia. Beyond the research, beyond some of the day-to-day work, what do you say the day-to-day has been looking like? How would you describe the internship experience at Orbtronics? And how do you like St. Lucia?
Well, St. Lucia is absolutely beautiful. I think it's definitely one of the more scenic places I've been recently. It's a far cry from New York. It's like concrete jungle. I guess sunset here is absolutely wonderful, and I've been really enjoying sort of walking around this area. Yeah, that's been wonderful. The food here is also really good as well. I'm really enjoying eating their cuisine. It's very international, so I would say it's semi-tourist centric, but it's been really good.
Yeah.
Beyond that, sorry, what was the first part of the question again?
So first part is what the day-to-day has been like, and then second question is how do you find the internship experience at Orbtronics?
So day-to-day has been very busy. I'm also doing a little bit of work on my side as well, because it's, I don't know, research work is quite convoluted. But day for me looks like I get up, I walk to the office here, and then at around sunset, so 6 p.m. or so, I get off work. I like to walk around the area a little bit. So while it's, the sun's going down, the clouds are beautiful, the mountains look really, really nice. So I tend to go walk around, get some food before heading back to my room and then, going to bed. So it's been very sort of, work-centric, but I've also really enjoyed like a lot of the free time. So on Friday, I went to the Friday night street party with you, as well as some other of the different lunch areas and the dinner areas, and that's been really interesting. I would say the culture is very different from what I'm familiar with. It's a lot more free. It's a lot more sort of, I would say very enthusiastic and very like lively compared to like a more corporate environment of New York or from Shenzhen, China. And that's been interesting. And I really do enjoy the environment here, and I want to come back sometime. Beyond that, for internship, I found it very enjoyable. It's cool to see it's cool to see environments of tech beyond of the like the larger countries or the larger developed economies. It's cool to see what these sort of things are sort of filtering down to like island nations like in the Caribbean, like St. Lucia, and it's interesting. And I really do enjoy the experience here.
Cool. Okay. So now something happened during the internship that most founders only dream about. You got news that you got accepted into Y Combinator.
Yes.
If some people from our audience don't know, it's one of the biggest accelerator programs for startup companies. They invest up to $500,000 into really early stage companies, and they've backed some of the largest companies like Airbnb, Stripe, DoorDash, and also Antonio. So take us back to that moment when you got the news. Where were you and how did you feel?
Of course. So I would say it was very much a big surprise to me as well. And it's a great honor to be a part of this cohort of the summer of YC. The news, I got it actually in the boardroom right over there. So I was on a call with Gustav, which is my general partner now in YC. It was definitely very exhilarating. So I think it was definitely a moment of great joy for me. And also it was a moment of great stress as well. So obviously now as you are joining a cohort, they're giving you a lot of investment. And with that investment comes with a very strong expectation of what you're going to do for them. Ultimately, YC and all these different accelerators, they are capital firms. They're venture capital firms. And they expect you to give them their return on investment with a good multiplier. So a lot of my work has been, in my free time, has been working on setting up the company properly, getting all the legal procedures set up, and seeing how you can effectively compete against these other companies. Because Y Combinator really wants you to be like the next Airbnb, the next Stripe, and that's going to be a lot of requirements, both legally as well as team building wise, and also a lot of technical details.
Yeah, very, very excited for you. I'm very proud that to call you part of our intern and part of the Orbtronics family, even if it was for a short time.
Yes.
I think now the floor is yours. Can you give us the pitch? Give us a little bit about what the startup is, what it does, maybe the pitch I got you into YC.
Yes, of course. So the company I work on, I guess the company that I now am founder of, is focused on low-cost mobile manipulators. Big terms. In essence, what it is, it's a generally on the market right now, there's a lot of humanoids. So you have Figure, you have 1X, you have Tesla, Optimus, right? The issue that I have with all of these larger robots is that they're really, really expensive. So I think a Figure robot costs around $50K, a Tesla Optimus, similar price range. And from what I heard, the Boston Dynamics Atlas robots are around $350K.
Yeah.
So a very out of touch, I want to say out of touch, a very expensive range. I mean, it makes sense for the engineering challenge to go through. They have expensive actuators, they have expensive control systems. And the sort of goal of what I want to do was to make that a bit lower cost and more accessible to the common people, or to the, I guess, a more normal environment. So initially the idea was that right now the main issue with robotics is not exactly in hardware. You can do a lot of really good things on cheap hardware. So basic VTech motors like a $13 or a $14 VTech motor can do majority of houseworks if put correctly, right? It can do things like washing dishes, like folding clothes. There's nothing that can be done on cheap motors. The main issue right now that's plagues the entire industry as a whole is the issue of data. So, with LLMs, the only main improvement that LLMs are seeing nowadays is all about data improvements. So these large models are not quite like people. They require, like I said before, an atrocious amount of data to be properly working out. And with robotics right now is that you don't have the same amount of data you have with LLMs. LLM data is just like web data. You have like books, you have websites, you have whatever. Anything that people write is already on the web. There's tons. It just is, I think, over like 8,000 years of written word language data that they can draw from. With robotics, it's not that case. Right. Now, obviously, there is a lot of different approaches to this. There's simulation-based reinforcement learning, which is a really good way of generating data if they work it out properly. There's ego-centric data, which is just capturing human hands and human working.
Yeah.
Obviously, there's still a gap between human embodiment and robot embodiment, which is, again, a big work done by a lot of billion-dollar companies right now. And the focus that I have is on imitation learning data. This is what's been most proven so far. So the work of generalist robotics and physical intelligence is all on imitation learning mostly.
Yeah.
And The issue is that you need to get a tons of data from different environments. So in different households, let's say you want to train a robot to pick up a clothes and then fold it. I think the current standard is that you need to run 400 episodes or so 400 demonstrations of you doing this in order for them to be able to replicate that action in a robot.
Yeah.
And in order to have that amount of data, you must deploy tons of robot everywhere. And in order to deploy a lot of robots is to get them to be very low cost. And that's sort of the initial angle we're going for. Obviously, currently we're focused on developers mainly. So we want to deploy to developers and researchers to help build out that initial framework. But in the coming years, maybe 2 or 3 down the line, we want to start deploying to households. And we want to make robotics as common as a household appliance, like a fridge or like a microwave. You have it, you activate it, it cleans your house when you're gone, and you can fold your clothes and you can just take your time off a little bit easier.
Yeah, I think that is immensely interesting. I think Orbtronics would love to have one. So that
Of course.
we could do some testing and tinkering.
I would love to send you one. Yes.
What are you hoping for to get out of this YC batch, and where do you see the company in a year from now?
So obviously from this YC batch, the main goal is to raise investment. So raise a really strong seed round. We're hoping to raise at $100 million cap post YC. That's our main goal. But obviously that's sort of a something that reflects how good the company is doing rather than the reflection of the company itself. So it's basically the goal in YC is to spend the first 2 months really locking in on the product. We want to build ideally the best low cost manipulator on the market, the best around $1,000 range robot out there ever. And then we want to compete with China, we'll compete with, we're a US company, so we're going to be manufacturing in SF the whole time.
Yeah.
And it really helps setting that initial supply chain, initial manufacturing line to allow us to reach those low cost targets, but also keeping a very sort of capable robot, right? We don't want to sacrifice any quality because we're aiming for a lower cost, because you're certainly able to be able to do all the different things that you have to do with the hardware, even though the software is coming up as the main sort of blockade. That's the sort of the main goal, to raise an insane amount of money and start deploying further. In terms of 1 or 2 down the line, obviously you're raising money for a larger purpose. And like I said before, our main goal, perhaps 1 or 2 years down, is to make robots first in elderly people's home and in disabled people's homes. So for a physical able person like me or you, right?
Yeah.
A robot can't really do what we do without it being atrociously in price. So I think there's this really cool demo from Boston Dynamics where they have their $250K robot pick up a fridge and then move it to a different table. Most people can do that if you're physically able.
Yeah.
And if you are not physically able, you're not going to be able to afford that $250K cost price point. It's dollars, by the way. And so when it comes to thinking about what can robot really do for people in the coming terms, it's mainly for those who are less physically able. So let's say somebody who's 80 years old can't really bend over and pick up a bottle of pill, or can't really fold their own clothes anymore, or somebody who's stuck in a wheelchair can't really go around their house and pick up things and put them back on shelves and whatnot. And that's where I really see the initial round of robotics really helping out, because despite the fact that these robots are not as capable as people, if you get them in these people's homes where they really need these basic functions that are sort of easier on the force strength, then you are able to improve their lives in a meaningful manner without it being atrociously priced. And so our goal is within the next year or so, you're first want to gather tons of data to feed into our base policies. We're going to probably train a few different act policies or a larger VLA policy, depends on what is going to be available for compute and seeing our testing with price points. But once we have that initial deployment, we want to start deploying it into autonomously into elderly homes and then seeing what impact it has. And we're hoping that's going to be positive.
Good. I think that's immensely interesting. I think the target market as well as where you see the entry point, I thought that was an interesting use case, and I think it's very much viable. I think one of my questions as well in targeting the low cost affordability price point, do you see that you need to have any innovations in material science or in some of your motors and sensors that would help you achieve that cost versus what's on the market right now and what's being used by your competitors?
So I would say we're not doing any material science innovation, right? We're not really inventing new ways of printing carbon fiber, or we're not necessarily doing new actuators either. Those are, I would say, out of scope for us. So we would really enjoy having better actuators, but we don't quite have the funding nor the bandwidth to build our own actuators.
Yeah.
And even if we did, it would be very hard to compete with these large Chinese companies like VTech or even Korean companies like Dynamax, who are mass producing these motors to get them at a very low cost.
Okay.
So in terms of that, not really too much innovation on the lower level of scales. So we're just going to use PLA and nylon that is 3D printed. In terms of innovation, we're mainly doing larger sort of system level improvements. So which motors to use, how to frame them, what is the larger design of the system. That's what we're really focusing on. And it's from our experience so far, like the past 3 months of working on it, it's been very effective in getting the cost down, and we want to continuously work on it. And obviously, if we were to move towards mass manufacturing, let's say if we're doing 1,000 a year, then we would want to start moving into the lower level aspects of like our own actuators and our own sort of material science. That is where we're going to be moving on in the future.
That makes sense. You're studying in New York. You've been accepted into Silicon Valley's top accelerator, and you spent this month doing frontier research in the Caribbean. What would you say to other students, especially young people here within the Caribbean region, who are wondering whether they can build at this level?
I would say I'm not from the Caribbean, so I don't know too much. But from what I've seen from, Nehal's my friend, of course, she also goes to Colombia with me. And I don't think where you come from really matters too much nowadays regarding to how, where you can go. In many ways, I would say Nehal is more proficient than me in engineering, and she's doing a lot of really serious research as well, which I would love to talk to her more about. But in terms of Y Combinator and Columbia University, a lot of these things comes down to just trying things out, and if they don't work, you just try again and again until it does. This definitely isn't my first startup, so I think I had close to 3 failed startups before I got to this point, and obviously each failure really hurts. You're like, oh wow, it didn't go well, and I guess I got to give it up, and then I wasted 2 months of my time. And I would say it's factor in what's available to you in terms of resources. And now a lot of resources in terms of AI, when you have these things, they're very low cost, and you can access an infinite library of knowledge just by using these things like Cloud Code or, even just the base cloud models themselves. That makes it a lot cheaper for you to learn things without having to go to an expensive institution like Columbia. That said, obviously there is a lot of benefits to going to a good college and good institution, which I'm sure you're familiar with when you went to MIT. I would just say do what you find interesting, and then see if you can pair that with something that's impactful. And if you can do those 2 things, I'm sure given enough tries and given enough time, you would find your own version of success for yourself.
Yeah, I think that is also very close to a mantra that we follow, and that I've been exposed to when I went to a program in Silicon Valley, JPA Heroes program. There was a thing that we used to say, fail and fail again until you succeed. So I think that's a very common thing within the startup world, and really within science and research, where it's really an iterative process. It's never that initially you have an idea and somebody just instantly came up with this big solution. It's normally because they tried many things, each one failed, and they made an incremental improvement to each failure, and it finally worked. So last one, would you recommend the Orbtronics internship experience? You could be honest, I can take it.
Yeah, of course. I think it's been wonderful here. I definitely really enjoyed this, and I will forward this program to other law scholars. So if you guys are willing, I would love to have more scholars come over and help you guys out, or just work with you guys. I think helping you is not quite working with you guys, learning from you guys, and building out that connection between Lay Law Foundation and Orbtronics. That'll be wonderful. It's been really good. I think it's definitely an eye-opening experience to see tech communities that are unfamiliar to me. Obviously, tech is something that I'm very much accustomed to, but it's awesome to see again, what it looks like in different formats across the world. And that's, I think, is eye-opening for any engineer, any software engineer, any hardware engineer, to go look at these different environments beyond America and beyond the larger tech countries. So yeah, I would definitely recommend it for sure.
Cool. Yeah, for sure. We'd definitely love to have more students and interns like you come and join us. And I think it was great having you. Thank you, Antonio.
It's wonderful.